All right, so we're going to go over 5.5, which is all properties of logs. So this is a pretty short section, but it is so important for the next section that we're going to go over. So one property is if we have log base a of 1, the answer is always 0. So if we have log base 4 of 1, that's because 4 to the 0 is equal to 1, right? So no matter what number I put here, anything to the 0 is going to be 1. If we have log a of a, so if they're the same number, log 3 of 3, the answer is always going to be 1 because, once again, 3 to the 1 equals 3. So if these are the same, the answer has to be 1. If we have a to the log base a, then they essentially cancel out. So if we have 2 to the log 2, the 2 and the log 2 cancel, and then our answer is just this guy, so 5. Same thing here, they essentially cancel out, so because a base is e here, the ln and the e cancel, leaving us just with kt, the exponent. Now this is an important one. When we are multiplying inside of our parentheses, we can expand that to be addition. So because we're multiplying the 4 times the x, we can expand it with addition, and then vice versa. Same thing here, when we divide, we expand that with subtraction. So x divide 2 is going to become x and then minus 2. Okay. This one, is another really important one. So essentially when we have an exponent, it can move to the front. So it becomes 2 log 4 of x. Then if we want to find our log, so let's say we wanted to find a log base 3 of 10, we could split that up to be log of 10 divided by log of 3. I would say these 3 are the most important and the ones we're going to be using the most often, but all of them are important. Okay, so if we look at number 1, it wants us to expand it, so we want it to get larger. So if we look here, we have multiplication, so we're going to expand that with addition. So we've got log base 2 of x squared plus log base 2 of 3x. Now another one of our rules is that when we have an exponent, it can move to the front. So this is going to become 2 log base 2 of x plus, now this is still multiplication, so I can break that up again. So log base 2 of 3 plus log base 2 of x, right? Multiplication gets expanded with addition. There's nothing else I can expand, so that's my final answer. Okay, and the next problem, we have division, and when we have division, we write it with subtraction. So we have ln x squared minus ln x plus 1. Division, subtraction. Then the exponent can move to the front. Now be careful, this is addition, so we cannot expand addition. We can expand multiplication with addition, but we can't expand addition, so there's nothing else we could do with the x plus 1. Okay, I'm going to leave number 3 for you to try, and then check your answers on the answer key. Now this problem is going the opposite way, so we want to write it as a single log. So because this is addition, we're going to rewrite this as log base 4 of x minus 1 times x. So we're going to take the insides and multiply, which would give us log base 4 of x squared minus x. This one, the first thing we have to do is move the 2 back up to be an exponent. So this would be ln x squared minus ln x plus 1. Now that the squared has moved up, because it's subtraction, we're going to rewrite it with addition. So x squared is on the top, x plus 1 is on the bottom, so that's our final answer. Okay, you guys try number 6. Check your answer on the answer key. Okay, so this is extremely important for what we're going to go over next. So on the next page, we're going to be solving logarithmic and exponential equations, but they're a little bit more complicated. So far, the problems that we've solved have been pretty basic. Now we're going to get into a little bit more difficult problems. So the problems we did on our last unit, or our last section, is if we have log base 6 of x equals 2, we're going to use exponentials to help us solve this. So we're going to go 6, because the base stays the base, and then the 2 and the x switch spots. So we end up with x equals 36. Now remember, when we're talking about logs, the base cannot be negative and the inside cannot be negative. This is not negative, so we're good. So I'll leave you guys to try number 2 on your own. Now number 3, this one is different, right? So on this one, I can't rewrite it because I have logs on both sides. So what happens when we have logs on both sides is that they essentially cancel each other out, leaving us just with x plus 9 equals 15. It's the same concept as if we have a to the x equals a to the y. If the bases are the same, then the exponents are the same. It's the same concept. If the logs are the same, then the insides are the same. Then we just use our basic algebra to solve. Make sure that this doesn't make anything negative. Good. Now in number 4, same thing. I have log base 8 and log base 8, but I can't ignore that there's a 1/2 and a 3. So remember on the last page, we talked about how the numbers in the front used to be exponents. So we're going to move them up to be exponents again. So we've got log base 8 of x to the half is equal to log base 8 of 3 to the 3. Now that we have log 8, because those are the same, the insides are the same. So x to the 1/2 equals 3 to the 3, which is 27. Now to get rid of a 1/2, we would want to square each side. A square times a half will eliminate. So 27 squared gives us 729. Make sure nothing is negative. We're good. So you guys try example 5. I'm going to move on to example 6. So on example 6, okay, now this time we don't have logs on both sides. We're adding the logs. So the first thing we're going to have to do is move the 2 to be an exponent. So we've got log base 2 of x minus 9 squared, because the 2 becomes the exponent. And then we learned on the last page that if we have log 2 of 2, right, 2 to the what gives me 2? Well, that's just the number 1. Right? That's a rule we learned on the last page. If these are the same number, then it's 1. So now we need to move the 1 over, so we're going to use subtraction. So we get log base 2 of x minus 9 squared equals 2. Okay, well, we don't have a log on each side, so we have to use our exponentials like we did on number 1 and number 2. So 2 to the 2 is equal to x minus 9 squared. Well, 2 to the second power is 4. Okay, so if this had an x in it, then we would have to multiply this out. But because this is just a number, it's actually easier to think about it as if this was just x squared, wouldn't you square root each side to solve? So we're going to do that same process. We're going to square root each side so that the square and the square root cancel, and we get 2 equals x minus 9. Now be careful, because whenever we take the square root, we can't forget about plus or minus. So we get plus or minus 2 equals x plus 9, which means we have positive 2 equals x minus 9 and negative 2 equals x minus 9. Now solve for x, add 9, add 9. So we get x equals 11 and x equals 7. So we get 2 answers, 11 and 7. However, remember, we have to look at, will anything make this negative? So if I plug 11 in here for x, I get 11 minus 9, we're good. That's a positive number. If I plug in 7, I get 7 minus 9, and that's going to give me a negative answer, which means 7 cannot be an answer, right? Because 7 is going to give us 7 minus 9, which is negative, which is bad. Okay, so only 11 is our answer. So number 7, we've got logs being added. So we need this to be 1 log, and we know from our last page that when we add logs, that's the same thing as multiplying them. So I'm going to write it as 1 log with multiplication. We also know from earlier in our unit, when there's no base, the base is 10. We assume it's 10. So now we don't have a log on each side, which means we have to use exponentials. So we're going to rewrite this as the base stays the base, the 1 and the x minus 3 switch spots. So we get 10 equals x squared minus 3x. So we're going to have to factor, so we're going to have to subtract that 10 to the other side. So we get x squared minus 3x minus 10. And then we have to factor, so it multiplies to negative 10 and adds to negative 3 would be x minus 5, x plus 2, which would give us positive 5 and negative 2. Now let's make sure that nothing makes this negative. So if I plug in 5 here, we're good. If I plug in 5 here, we're good. So x equals 5 is good. If I plug in negative 2, that makes that negative. So we're not actually allowed to have negative 2. Okay, let's look at number 8. So number 8, I have logs on each side, but I also have this 1. So I can't just ignore the 1 like we did in number 3 and just say log equals log. We still have that 1 there. So we needed to look something like this where both of the logs are on the same side. So our first step is we're going to subtract this log of x minus 3 to the other side. Now I'm not allowed to combine these, they're not like terms, so I just have to leave it as log 4x plus 4 minus log of x minus 3 equals 1. Now I need this to be 1 log, and we know from our previous page that when we have subtraction, that means we can combine it with division. So 4x plus 4 is on the top, x minus 3 is on the bottom, and that equals 1. The base is then 10, so we'll rewrite it. 10 to the 1 is equal to 4x plus 4 over x minus 3. To get rid of the fraction, multiply by x minus 3. So that gives us 10x minus 30 equals 4x plus 4. Get all your x's to the same side, all your numbers to the same side, and solve. So subtract the 4x would be 6x, add the 30 would be 34, divide by 6. 34 divided by 6 gives us 5.667. If I plugged that in, would anything be negative? It would not. So that is my final answer. Okay, number 11. So we've got 2 ln's being added. So we're going to use multiplication to rewrite this as 1 ln. Now that we have it as 1 ln, we can write it using exponentials. So remember, ln has a base of e. So it's going to be e to the 3rd power equals 3x plus 6. All right, I distributed. Subtract the 6 over, e to the 3rd minus 6 equals 3x. Divide everything by 3. We get x equals e to the 3rd minus 6 all over 3. That's the exact answer. To get the decimal answer, we would plug it in. So we would do e to the 6th power, no, 3rd power, minus 6 over 3 gives us 4.695. Okay, number 12, we have on this side, the 2 is going to have to move up to a exponent. So we've got log base 3 of x minus log base 3 of 5 squared equals log base 3 of x plus 1 minus log base 3 of 10. We know with subtraction, we can make it 1 log using division. So this becomes x over 25, because 5 squared is 25. X plus 1 over 10. We have logs on both sides, so look at the inside. X over 25 equals x plus 1 over 10. Cross multiply, we get 10x equals 25 times x plus 1. Make sure you distribute. 10x equals 25x plus 25. Subtract the 25 over. Divide by negative 15. You get negative 5 over 3. Now, remember you have to make sure that nothing became negative. So if I plug in negative 5 over 3 here, isn't that going to give me a negative? And if I plug it in here, that's also going to give me a negative. So that doesn't work. So this answer is actually no solution. Right? So when that doesn't work, our answer has to be no solution. Okay, number 15, so we're going to have to move the 2 up to be an exponent, move the 3 to be an exponent. So we 2 to the 3rd power. Then we have a plus, which means we can multiply, so times 4. Now we have log base 3 on each of these, so we've got x minus 1 squared equals 2 to the 3rd would be 8 times 4 would be 32. Now remember, because there's no x here, I can just go ahead and square root each side, which gives me x minus 1 equals plus or minus. Now 32 can be 16 times 2, which would be 4 root 2, plus or minus 4 root 2. Add the 1 over. So we get x equals positive 4 root 2 plus 1. And then we get x equals negative 4 root 2 plus 1. If I plug this in, I don't have any issues. If I plug this in, this is going to be a negative number. Minus 1, that's going to make it more negative, so that's not going to work out. Okay, now number 16, I'm not going to solve all of the way, but I wanted to at least get it started for you guys. So remember, the 2 is going to move up to be an exponent. So we've got log base 4 of x plus 3 squared equals log base 4 of 6x plus 19. So because both of these are log base 4s, we can set these equal. Now in this problem, when I had x minus 1 squared, I could square root each side. Now that's only because this is just an integer. If I look over here, if I square root each side, I'm going to be square rooting an x, and that's not going to really help us. So I cannot do that same method here. So what instead we have to do is distribute this out. So x times x would be x squared, 3 times x would be 3x, 3 times x would be 3x, and then 3 times 3, 9, because remember, x plus 3 squared is x plus 3 times x plus 3. Get our x's to the same side. The x's cancel out. So that gives us x squared plus 9 equals 19. Subtract 9 from each side. We get x squared equals 10. Square root, square root. 10 cannot simplify, so we get plus or minus root 10. But if I had a negative root 10, that's going to make this negative, which is not okay. So it is actually just the positive.